Okay, so it's good to be back at Bol.com premises. Yeah. And today we're talking with Mattijs and Bart about hexagonal architecture and domain-driven design.
I'm Mattijs Meiboom, and I'm a software engineer at Bol.com for 8 years now. And I've been doing that in all kinds of parts of the company and seeing how it grew over time. As many people probably know the company as a web shop selling loads of different products within the logistics domain mostly. So physical stuff, shipping, returns, invoicing of everything that was shipped. So there's a very strong connection to a physical domain in the teams I've been acting in and writing software for. And that, to me, also was a perfect place to use that domain, that physical reality, as a part in designing that software. And, well, in comes domain-driven design and thinking about how to separate your functional or your domain from, well, all the technical stuff we deal with on a daily basis as well. Your logging and your metrics and your framework underneath and your deployments, etc. So jumping in to then what means hexagonal architecture or domain-driven design to me. I'm not a purist, so I'll keep it emphasizing on to me. But to me, it means trying to get a very good understanding of the domain you're working in, whether that's writing software or maybe doing data analysis or business analysis or anyway, coming up with solutions. And able to do that, to really use that strength, we need to understand that domain very well. And that means that anything that distracts me in my software from that domain, or that, well, kind of dilutes that domain, like all the technical details in your chosen framework, that's a distraction, and I want to keep that away. So, writing your software in such a way that you can really let the domain speak as much as possible. And so far I found that those strategies help me do that.
Yeah, so maybe Mattijs, for those of you who haven't encountered the term before, maybe you can explain quickly what the basic idea of hexagonal architecture is.
Sure, and maybe this would be a good point to start drawing as well at some point. Yes, we've cleaned the whiteboard, and that should have a reason, right? Anyway, we've dropped some terms already. So we've dropped inside, outside, or functional, or technical, and domain. Anyway, it's about isolating. It's about shielding your domain, maybe making it more changeable, regardless of your stack. But what it would look like in practice, and some people call it ports and adapters architecture. I hope it will be clear why soon. Anyway, simple application example. You would have some HTTP requests. Maybe you're serving on your service. HTTP protocol, that's definitely technical, right? It's your domain probably doesn't care about HTTP that much. So instead of directly processing service logic, returning a response, we would have some kind of class being able to deal with the protocol and then converting that to a request on your domain language. So instead of doing some get v1, we talked about returns. So let's say we want to get the status of a return number one. Some technical kind of language request, right? And that translates, so we maybe have a Spring REST controller or something that is able to take that and convert it to a nice POJO, maybe retrieve status for return, whatever, but something that makes sense in a business kind of way. And it will actually ask some domain service to do that. I'm going to change some things up later, but for now I'll just simplify it. And so this will be kind of a controller. Yeah, this will be interesting. We have some service or some domain logic able to, interpret that. And we'll assume we'll have a database with all the state and the latest information. So service goes to database. Let's make a nice database, like DB. Right, so we reached the database. Awesome. And it will return things and finally have a response to your request. But yeah, anyone who has at least some experience with software architecture probably thinks, okay, you've just drawn a layered architecture, but sideways. But yeah, right. So we have our controller or view layer, we have a service layer, and then we have a persistence layer, which is nice. But it also means that the service is really directly depending on our database. It knows about it. It's definitely not isolated from that world outside. So what hexagonal architecture says or recommends is, making use of dependency inversion in this case to put the service as our crown jewels, our domain logic, our business rules, and isolate it completely from the outside. So, dependency inversion, we put some kind of interface specification as part of the domain saying I need some place where I can retrieve the status of probably persisted, maybe it doesn't even know. Anyway, retrieve the status of returns, and the database is just an implementation of that interface. So we've inverted the dependency direction, and the service doesn't care about the outside anymore. Still, the service does need to publish some way of the outside world to interact with it. So the service itself also exposes some interfaces or an API that the controller can use. So usually, we draw it in front there, which is implemented by the service, some public interface of what it can do, which is called by the controller. This kind of mechanism here is why some people call this ports and adapters. The interface is a port or some way in and out of your architecture to transfer between technical functional. And the implementation of that port is called the adapter. So that could be a database adapter like a JDBC Postgres adapter, whatever. But it could also just be the service implementing some provided service. The other name we've mentioned a couple of times, hexagonal architecture. Well, that doesn't really show yet from this picture. So what I'll do is I'll draw the kind of the boundary between our domain and the outside world. Because of course, usually we have several ways in. We could have a REST API. But if you're doing kind of a status thing, we might also have an admin API for for some completely other operational stuff going on, which has a separate authentication or maybe a different kind of protocol. I don't know. Anyway, yeah, could even be not even be HTTP JSON, but some other marshalling. So anyway, different ways in, or at least different ways from the outside technical. And it might also be that we have several dependencies that we use, not just a database, but we also want to enrich with some real-time remote HTTP call, maybe to our operator in the warehouse.
Maybe you have more than
right?
one surface in your landscape.
Maybe you have a microservice architecture. You have all these kind of dependencies with a little piece. I don't know. I don't know that situation. Anyway, that could be many dependencies of your domain, right? The bigger it gets, and at some point you probably split it, but in general, it's not a one-on-one simple app. So, someone at some point thought, okay, to emphasize that this is not a layered architecture, but it's really about the inside and the outside, and this marker is not that good, but let's try, is that it draws a hexagon. Well, now I have to start counting as well. So, there we go. The boundary is really explicitly there, and there's all kinds of facets of transferring into your domain, and drawing a hexagon kind of emphasizes on outside, inside, which one of the other terms used. And then I think to reflect a bit on what that makes so nice. Well, if it's just single REST call, probably not that much. Then you really get those extra layers in between, and we said, well, that might be a bit much. But if you depend on a lot of different services, and now suddenly this service that maybe you don't even own, but they change their API, they change their networking protocol or whatever, then you're, by definition, because if you respect the boundaries, you're at least guaranteed that the change will be isolated to only this part of your application, your driver, whatever adapter you have. And usually that makes you very resilient against that change.
Perfect. I think that's a very nice schematic depiction